In the last two videos, we looked at different ways that we can solve two by two systems of linear equations. We looked at solving them with graphing, substitution, and elimination. Substitution and elimination are going to be the two primary ways that we go about solving these because graphing tends to be a little bit inconvenient sometimes. So what we're going to do now is we're going to take these two different methods for solving systems and we're going to apply it to some different application problems. So the main thing that's going to be different here is that we're not given our equations. So we're going to be given a described situation and we have to read through it, figure out what our variables are, find our equations, and then solve that system using the techniques that we learned before. So let's go ahead and take a look at example one. All right, and I'm just going to kind of highlight important information as we go. All right, so it says a customer in a coffee shop purchases a blend of two coffees. So we have Kenyan coffee, which costs us $3.50 a pound. Then we have Sri Lankan coffee, which costs $5.60 a pound. He buys 3 pounds total, which costs him a total of $11.55. Okay, now then the question it's asking us is how many pounds of each kind went into the mixture? Now, it's always important with these word problems to focus in on what you're actually trying to find. Because when we start these, the very first thing I want you guys to do is define your variables. Tell me what is X measuring and what is Y measuring. And the way that you can figure that out is by thinking about this question. So here it's asking us how many pounds of each kind of coffee went into the mixture. Well, our two kinds of coffee are the Kenyan and the Sri Lankan. So I'm going to define my variables. So the X is pounds of the Kenyan coffee and Y is pounds of the Sri Lankan coffee. Okay, so when you're defining these variables, be as specific as you can. So I don't want you to just say X is Kenyan, Y is Sri Lankan, because Kenyan what? Sri Lankan what? So you have to focus in on, well, what are we actually measuring? And in this case, what we're measuring is the pounds of these different types of coffees. So think about all those important pieces that go into defining these variables and include as much detail as you can when you're defining them. Okay, so once we know what our X and Y are representing, the next thing we need to do is actually build our system. Okay, now if we look at what we're given here, okay, we know we need two equations to go along with our two variables. And there's basically two things that they're talking about. They're talking about the total number of pounds of coffee that he's purchasing, but we're also looking at the total amount of money that he paid. So essentially, one of our equations is just going to be dealing with the pounds, and the other equation is going to be dealing with the total cost. Okay, so we know that X is representing pounds of Kenyan coffee, Y is representing pounds of Sri Lankan coffee, and he buys a total of 3 pounds. Well, in terms of an equation then, that would just mean X plus Y is equal to 3. Right? Pounds of Kenyan coffee plus pounds of Sri Lankan coffee has to add up to a total of 3 pounds. All right, so then like I said, the other equation is going to be dealing with the money. So what we know here is that the Kenyan coffee, or our X, right, costs $3.50 a pound. The Sri Lankan coffee, or our Y, costs $5.60 a pound. And we have a total cost of $11.55. So 350 X plus 560 Y is equal to 11.55. Okay, because you're looking at $3.50 for every pound of Kenyan coffee plus $5.60 for every pound of Sri Lankan coffee for a total of $11.55. Okay, so now that we have our system built, this is a problem just like we were doing in the previous videos, and we just need to solve it. So I'm going to label these as equations 1 and 2. All right, and we can solve using any technique that we want to. We can do substitution, we can do elimination, that's completely up to you, okay? I'm just gonna do a little bit of both as we go through this video just to help you guys make sure you get practice with each technique. Something that you could do as you're going through this would be to pause the video and try to solve it using the other method that I'm using and just compare answers at the end and make sure that they came out the same if you want to get practice. Okay, so I'm going to go ahead on this one and I'm going to use substitution. Okay, that one looks a little bit easier to me maybe on this one, but really I'm just making a choice. So I'm going to do substitution, and definitely it looks like the first equation is going to be easier to solve for one of our variables. So I'm going to take equation 1. Okay, and remember with substitution, it doesn't matter whether you solve it for x or solve it for y, you'll get the same answer. So I'll just go ahead and solve for x because it's first. So we would get x is equal to 3 minus y. All right, so then we substitute this. And we always have to substitute it back into the other equation. So we would get 350, and then in place of our x, we're going to plug in 3 minus y plus 560y equals 1155. Okay, so now we want to try and solve for y. So distribute the 3.5 in. So that'd be 10.5 minus 3.5y plus 5.6y equals 11.55. Combine our like terms. So negative 3.5y plus 5.6y. We'll have 2.1y. And then subtract the 10.5 over to the other side, and we'll end up with 1.05. And then if we divide by 2.1, we'll end up with y is equal to half a pound. And remember, our y was pounds of the Sri Lankan coffee. So half a pound of the Sri Lankan coffee. All right, so that's one of our answers here. All right, last thing we have to do then is just back substitute this in order to find our other variable. The easiest place to plug it back into will be this equation that we just solved for x. So x is equal to 3 minus 0.5, or 2.5 pounds of the Kenyan coffee. Now, when you're doing these word problems, you can put it in an ordered pair if you want to, but you don't necessarily have to. We're not so much looking at a point on a graph necessarily with these. I mean, you are, but that's just not the way that we're necessarily thinking of it. It's more helpful just to describe, well, what is that x that we just found and what is that y that we just found? And you can just leave them sort of as their individual answers here instead of rewriting them as an ordered pair. Okay. All right, so that's our first example. Let's go ahead and look at a second one. Okay, so this time we're looking at renting a car. So again, I'm going to highlight as I go. So you're choosing between 2 car rental agencies: Enterprise, which charges $40 a day plus 10 cents a mile; Hertz, which charges $50 a day plus 8 cents a mile. You figure out that Enterprise will cost you $310 and Hertz will cost you $320. All right, so then our question is how many days are you renting the car for, and for how many miles do you expect to travel? Okay. All right, so let's start again by defining our variables. So this time the question it's asking us is how many days are you renting the car for and how many miles do you expect to travel? So we want to define our variables as days that the car is rented and miles that are driven. Okay, whatever the question is, that's going to be how you define your variables. So I'm going to let x equal days rented and y equal miles driven. Okay, focus in on that question to help define your variables. All right, now we need to build our system. Okay, so to go along with our two variables, we need two equations. Now the two different things that we're looking at this time are the two different car rental agencies. We have Enterprise and Hertz. So each of our equations is going to be for those two different car rental agencies. So I'm going to focus in on Enterprise first. So with Enterprise, we were told that they charge $40 a day plus 10 cents a mile. And it also told us that Enterprise will cost us a total of $310. So $40 a day, okay, remember X is days, so that would be 40X. 10 cents a mile, our miles driven is Y, so plus 0.1 Y. And then for a total of $310. So that's our first equation. All right, second equation then, we're going to look at Hertz. So it says Hertz charges $50 a day plus 8 cents a mile. And Hertz is going to be a total of $320. So $50 a day means 50x. 8 cents a mile means 0.08y. And then for a total of 320. All right, so there's our system. Oops. And now we just need to solve it. So again, we can solve using whichever technique we want to. We can do substitution, we can do elimination. That's completely up to you. I'll go ahead and do substitution again. So if we want to substitute, we just need to pick one of the equations, solve it for either x or y, and then substitute it. So I'm going to go ahead, I'm going to pick equation 2 on this one. And I think it looks a little bit easier to solve for y. So I'm going to subtract the 50x over. And then if we divide by the 0.08, we're going to end up with negative 625x plus 4,000. All right, so then that we can substitute back into our other equation. So this was equation 2, remember? So we're going to substitute this into equation 1. So we'll have 40x plus 0.1 times, and then here's where we substitute in our negative 625x plus 4,000. And that's equal to 310. All right, so now we just need to solve this out for x. So I'm going to distribute my 0.1 in. So the 0.1 times the negative 625 is going to give us, should be a minus negative 62.5x, and then plus 400 is equal to 310. Combine our like terms, so negative 22.5x, and then subtract the 400 over to the other side, that would equal a negative 90, and then divide by the negative 22.5, and we end up with x is equal to 4. If you go back up here, remember we defined x as the days that we rented this car. So this is 4 days. that we're renting this car for. All right, lastly, we need a back substitute to solve for y. So I'm going to go ahead and just plug it right back in here. Okay. So we'll get y is equal to negative 625 times 4 plus 4,000. And if we work that out, we end up with y is equal to 1,500. And remember, y was the miles driven. So 1,500 miles. So that is our final answer. Okay. And like I said in the last video, if you want to write this as an ordered pair, you can. You can write it as 4 1,500, but it's also okay just to leave them separate and either just make sure to box or highlight your answers so that we know what's what. All right, guys, I'm going to go ahead and end this video here, but I'll do a second video with a few more examples if you want to see a couple more of them worked out.